The next section is inelastic collisions. And the idea about inelastic collisions is that they are going to stick together. Two trains can couple, they stick together. Maybe two cars, when they get in an accident, their bumpers lock and they stick together. And a lot of times when you have an inelastic collision, the idea also is that we're going to lose some energy due to transformation into heat, deformation. So if it's perfectly elastic, we have no loss. And then if it's inelastic, we have some loss. So we're not going to talk about that loss at all, though. So all the energy is going to be conserved through the equation. We're not going to talk about whatever we lose. Anyways, inelastic collisions where they stick together. So as before, we talked about P equals mv, where m is the mass and v is the velocity. So once again, here we have a mass that is moving with a certain velocity, and it is going to run into, so this is the before, it is going to run into an object, and it is going to stick to it this time, and they're going to move together. And so this is after. So when you look at that, mathematically, just to simplify it, we have mv, and then we have plus mv, and then bam, equals this object stuck to this object, moving together. So we bracket it, and we add their masses like this with one velocity. Now the opposite can be true if you have a gun, or in the case of Valentina the cosmonaut, they'll be together first, and so we'll kind of reverse this situation depending on how the question is asked. And so you'll see this down here. So Valentina, she's lost in space. Her tether has been cut, but she's got a camera. So she has to make a decision. Do I lose the expensive camera and survive, or do I just sit out here in space thinking about it? So the camera doesn't weigh very much, but it doesn't matter because in space there's no friction. So she might not go back to the spaceship quickly when she throws the camera, but she will sooner or later. So now they're together, actually, and now they're apart. So this is the opposite equation. Valentina with the camera. The equation here would be Valentina with the camera, and this is their velocity. And then the equation after is Valentina separate from the camera. And it's as simple as that. Valentina with the camera and Valentina separate from the camera. So don't overthink it. Just draw the steps and put the equation in, and then substitute. This is when you should start thinking, really, is when you're substituting. It says, how fast will Valentina travel toward the spaceship? So what we're trying to find here is this one right here. That's our question. So I'll continue that in red. So Valentina and the camera together are 68 plus 2. And their velocity is 0. So it doesn't really matter what it is here, because this is going to be 0. Their momentum is 0. 68 plus 2 is their mass, but their velocity is 0, so this is 0. And her mass is 68 without the camera. And the mass of the camera is 2. And the velocity of the camera, when she throws it, is going to be 12. So I have 0 equals 68v plus 24. I minus 24 from each side, so I get negative 24 is equal to 68v. And then I get my velocity is going to be equal to 24 divided by 6 is 4. So it's a negative 4 meters per second, which means the camera goes this way at 12, and Valentina is going to go that way at a negative 4 meters per second. And all the questions are the same. You can either be together and then apart, or you can reverse it and be apart and then together. And these are inelastic. So page 2 is all inelastic, and page 1 is all elastic. Page 1 is all bouncing, and page 2 is all sticking together.